Algebra 1, Lesson 48, Polynomials, Degree and Addition of Polynomials. So up till now, we've been working with polynomials pretty regularly, even though the book hasn't clearly told us what they are. We've been working with them. And just about every single algebraic number can be expressed as a polynomial. And the reason why is because polynomials take up the form of a coefficient, a variable, and an exponent. So the most common forms, we see stuff like this. For x squared, we've got our coefficient, we have our variable, we have our exponent, right? And this would be called a second degree polynomial, degree referring to the number in the exponent. We could take something like 2x to the power of 4. This is a fourth degree polynomial. We could take something like 3p cubed, third degree polynomial, right? So degree refers to the exponent, the number of the exponent. Now, why can we say that just about every single number is an algebraic expression or a polynomial? Well, let's take the number 4, for example. You look at the number 4 and you say, well, there's no variable, there's no exponent. Yeah, there is. It's just invisible. You don't see it. If I put x to the power of 0 next to 4, did I change the number? No. Remember, x to the power of 0 is equal to 1. 1 times 4 is 4. So every single term can be thought of as a polynomial. There's just some pieces that we may or may not see. So, and then even x, if we just take the letter p, that's a polynomial. That's a polynomial as well, because it's got a coefficient of invisible 1 and it's got an exponent of invisible 1. So it's got a coefficient, it's got a variable, it's got an exponent. So just about every single number can fill this role. It's just we may or may not see all the pieces of that number based on rules of simplification. Now, this is referred to as one term. So a single polynomial is referred to as a single term. If we have a polynomial being multiplied by another polynomial, if these are being multiplied, well, that can be simplified as a single term as well. So this would just be called a polynomial expression, and it can be simplified into one term of 8x to the power of 6, single term. Now, what changes is, let's say I take these two polynomials, 4x squared plus 2x to the power of 4. That plus sign now makes this a binomial. So this is called a binomial. The reason why is because we now have two polynomials. They are not like terms, so they cannot be added. So addition and subtraction signs make polynomials very difficult. Multiplying and dividing them, simple. Adding and subtracting them, not so much. So let's do some practice problems that explain this. Oh, also, as far as polynomial degree, it's usually algebraically proper to write polynomials in descending order. So if you have an additional like terms problem, with x3, x4, x5, you'd write the answer in descending order. We'll see a couple examples of that very quickly. So our first example, we have x cubed plus 3x squared plus 2 in parentheses plus 2x cubed plus 4. All right, so we have some polynomial expressions. They're being added up, and the term polynomial refers to any polynomial expression that has 3 or more, I guess 2 or more terms in them. So we've got 1, 2, 3, 4, 5 terms, polynomial. So what I can do here, since this is just addition, I can distribute this positive, which is not going to change any signs, and just make it plus 2x cubed plus 4. This parenthesis can go away as well, since all we're doing is adding. There's no other multiplication or division, and there's no other distribution that needs to happen. So now I just need to add like terms. I'll add 1x cubed and 2x cubed to get 3x cubed. There's no other x squared, so I'll just put 3x squared, positive, and then 2 and 4 will combine to become plus 6. And so this is my final answer, and what I've done is I've written this in what's called descending order, which means the highest exponent is to the left, and then it slowly shrinks down from there. Now this example is pretty easy. I'm going to show you another example. It's a little bit more difficult, but it helps us learn something. We have 3x squared plus x to the power of 4 minus 6x plus 2 minus 15x to the power of 4 plus 2x cubed minus 6x squared plus 5x minus 3. All right, do I still have your attention? I hope so. So this is a lot of terms going on. Now, the key thing here is there's a negative sign in front of my parentheses. Whether this negative shows up here or here, it means I have to distribute it. The same way I distributed the positive up here, I'm going to distribute the negative. Now, when I distribute a negative, all my signs change. The positive keeps everything the same. The negative changes everything. So when I distribute here, this becomes negative 15x to the power of 4. This positive 2x cubed becomes negative 2x cubed. This negative 6x squared becomes positive 6x squared. This positive 5x becomes negative 5x. Positive 3 becomes negative 3 becomes positive 3. All right, and now I have to put these terms in front of it, and these signs do not change because there is no negative. And I need to combine like terms now. If you forget to distribute this negative, it completely changes your answer. So let's start with the highest term. The highest degree is of 4. I've got positive 1 minus 15, or plus negative 15. That gives me negative 14x to the power of 4. Let's see here, 3. I've got 1, 3. It is a negative 2x cubed. You notice there's a lot of terms going on here. So what I'm going to start doing is I'm going to start crossing out the ones that I've dealt with, so I don't actually accidentally write any twice. So I've dealt with 3. Let's go to the second degree. I've got positive 3x squared, positive 6x squared. Those combine to become 9x squared. Then I have negative 6x, negative 5x. Negative and negative add up to become negative 11x. Then I have positive 2, positive 3. Those combine to become positive 5. Our final answer is all of this. Negative 14x to the power of 4 minus 2x cubed plus 9x squared minus 11x plus 5. And that is it. If you have any questions, let me know on Moodle, and I will see you in class.